Assalamualaikum warahmatullahi wabarakatuh. Hello, distinguished faculty and fellow doctor candidate, especially for our lecturer, Dr. Fajri Muharja. I'm Ovanto, and today I will be presenting a critical analysis of fundamental paper in contemporary mechanism design. The title is Dominant Strategy Implementation in a Large Population Public Goods Game. Authored by Ratul, Lahkar and Saptarshi Mukherjee and published in the reputable journal Economic Letter in 2020, this study explored how mechanism design can achieve efficiency in public good provision when the social planner faces the informational constraint regarding agent to prevalent with a massive population scale. So why is this study vital for us as economic researchers? The fundamental problem in the public good is the provision is the efficiency gaps. Traditionally, individuals lack of the incentive to internalize the positive externalities they generate, leading to well-unknown phenomenon of free riding. In the history of mechanism design, we recognize the VCG mechanism, which granted truth-telling but often failed to achieve the strong budget balance, meaning the planner must provide external subsidies. Conversely, the AGV mechanism balanced the budget but failed to ensure the ex-post voluntary participation. Now, Lahkar and Mukherjee offer a resolution to this trilemma by adopting the large population or continuum of agent approach. Here the assumption of atomistic agent become the master key to simplifying complex incentive structure. Now let us examine the model environment. The author assumes a society with a total mass of 1. These agents are divided into finite types, yet the number of individuals within each type is continuous. Observe the payoff function displayed on the screen. The benefit from the public good is common benefit, depending on the aggregate strategy or the total contribution of society. A crucial point here is the nature of function. The benefit function is concave, and the cost function is strictly convex. Because each agent is atomistic, possessing zero mass relative to whole, a single individual strategic decision cannot alter the aggregate value. This property is exactly what we will use to establish truth-telling as dominant strategy. And now we are having understood the economic environment. The next question is, how can social planner with no prior information on distribution of agent type steer society toward the optimal state? So let us move to the mathematical derivation of the efficiency condition. The socially efficient state is achieved when the total aggregate welfare is maximized. In proportion 2.1, the author derived the first order condition which served in generalized of Samuelson rule. Mathematically, a state is efficient if the social marginal benefit of the public good exactly equal of the individual marginal cost for every agent type. However, an informational challenge arises. The planner doesn't know the agent, the true type of the set, this contribution unilateral. Therefore, the mechanism is required that can induce the agents to reveal their private information truthfully through an incentive structure. The author introduced the mechanism G. This mechanism worked by requesting a type report from the agent. Based on this report, the planner determined two things. One, the contribution of level, and a Pigouvian transfer. The Pigouvian transfer is designed to cover the gap between private costs and social benefit. The greatest innovation here is the informational shift. The mechanism does not depend on the planar knowledge of the population distribution at the outside. Instead of this self-correcting based on the incoming aggregate report, thereby reducing the informational burden on the social planner. And we now arrive to the core finding of this paper. The achievement of strict dominant strategy implementation in a finite population economy, our report affect the other outcome. However, in the continuum population, we observe the strategic irrelevant because an individual report does not change the aggregate variable. Every agent perceives the level of the public goods as the fixed or givens. The agent's maximization problem is then reduced to maximizing a private payoff function that depends solely on their own report. The author proved that reporting the true type is the only way for an agent to reach optimal point. This is why honesty becomes a strict dominant strategy regardless of what million of the other agents report. Another advantage of mechanism G is fiscal sustainability. Through mathematical proof, the author demonstrates strong budget balance. The total subsidy given to high-cost agents are exactly financed by the tax or deduction from the low-cost agent, meaning the planner requires no external fund. Furthermore, the mechanism satisfies the exposed individual rationality due to the curvature of the benefit and cost function. Every agent net profit under this mechanism is always greater than zero. This provides a guarantee that participation in provision in these public goods is voluntary and Pareto improving for all parties involved. Okay, if we look back at the comparison metric, mechanism G surpassed the limitation of classical mechanism. We are no longer discussing about the weak honesty or a budget balance that only occur on average. We have a system that is robust against individual manipulation and stable financially, making it an ideal solution for large population economic models. Last but not least, in conclusion, Lahkar and Mukherjee article successfully proved that in the large population economic system, the trilemma between efficiency, honesty, and budget balance can be resolved. The implication for reaching first efficiency can be implemented in the strictly dominant strategy. Second, the planner informational burden is minimized. And the third, it provides the scalable framework for real world of public policy. That concludes of my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.